Dot School presents linear inequalities. A linear inequality is a math statement in which the left-hand side is less than, equal to, greater than, or greater than equal to the right-hand side. For example, we could say 4y is less than 20, or 4y is less than equal to 20, which means it is less than or equal to 20. Or we could say 4y is greater than 20, or 4y is greater than or equal to 20. All four of these are different inequalities. Now, if you want to solve for y, let's say on the first one, you would go ahead and divide both sides of the inequality with 4. Pretty much as you do with equations, which means y is less than 5. In the same way, on the second one, we have y is less than or equal to 5. Note that y is less than 5 means y can be any number as long as it's less than 5. And on this one, y can be any number as long as it's less than or even equal to 5. And you can do pretty much something similar with the other two. For this one, it's going to be y is greater than 5. And for this one, the solution would be y is greater than or even equal to 5. And this means y can be any number as long as it's larger than or equal to 5. For example, y could be 5, 5.5, 6, 10, 20, 100, 1 million. It could be anything. And if you multiply 4 with that value of y, you will always end up getting a number that's greater than or equal to 20. So one important difference between an equation and an inequality is that in an equation you have one answer. In a linear equation there's only one number that fits in. But when it comes to an inequality, you can have an infinite number of answers that would fit in place of y. So it's impossible to write down all those numbers, obviously, that would fit in place of y. Therefore, the answer is also written in the form of an inequality, as you see over here. We can pretty much solve inequalities using the same rules as we do with equations, with a couple of crucial exceptions that I will talk about a little later. Let's do an example. Let's say 5y plus 4 is less than equal to 2. Which means if you multiply 5 with y and add 4, you get a number that can either be equal to 2 or anything less than 2, but never something more than 2. Or what are the possible values of y? So as we do with equations, we are going to take this constant on the other side by subtracting 4 from both sides of the equation. So that in the next step, these two cross off and we have 5y is less than or equal to 2 minus 4 is negative 2. And to solve for y, we divide both sides with 5 to get y is less than or equal to negative 2/5. This answer means y can be any number out here as long as it's less than, smaller than negative 2/5 or negative 0.4. Let's try another one. Let's say we have 3x plus 1 is greater than x plus 2. The idea is to have all the x's on one side and all the constants on the other side. So we should subtract x from both sides, minus x, and subtract 1 from both sides, minus 1, so that these two cross off. We have a 0, we don't have an x on the right hand side anymore, and these two cross off. We don't have a constant on the left hand side. 3x minus x is 2x, and 2 minus 1 is 1. Therefore, 2x is larger than or greater than 1. If you divide both sides with 2, you have your solution to the inequality x is greater than 1/2. Which means x can be any number on this one as long as it's larger than 1/2. It could be 1, it could be 2, it could be 2/3, it could be 3/4, it could be 100, 1 million. As long as it's larger than 1/2, it's fine. It seems until now that solving linear inequalities is exactly the same as solving linear equations. But you need to be careful about two things. Imagine you have 1 over x is equal to 1 over 2 or 1/2. So what's x? X is 2, right? Therefore, you can flip the numerator and the denominator in an equation. However, can we say the same thing about an inequality? Let's find that out. Let's just say 1 over x is greater than 1/2. Now, does that mean we can flip these over so that we have x is greater than 2? Try something that's larger than 2 for x over here. Let's say 3. So is it right that 1 over x, which is 1/3, is greater than 1/2? This is wrong, which means this is not right. When we flip over the numerators and the denominators of both sides of an inequality, please keep in mind that you need to flip the sign as well. X is going to be less than 2, not larger than 2 as on this one. There's another exception. If you're multiplying or dividing both sides of an inequality by a negative number, the sign needs to be flipped. Consider this. Negative 2x is less than 6. Now to find x, we're going to divide both sides with negative 2. Therefore, we have an x on this side, and 6 divided with negative 2 is negative 3. Now when you do that, you divide with a negative number, the sign needs to be flipped. The less than changes to a greater than. So x can be anything as long as it's larger than negative 3.